Today's lesson is about a second derivative and its graphs. First of all, let's talk about the second and higher derivatives. Given a function f of x, the derivative f prime of x or f dashed x is known as the first derivative. The second derivative of f of x is the derivative of the first derivative of fx. We use this symbol to show the second derivative of f of x. This symbol read as f double dashed x. This symbol read d2y by dx squared. The nth derivative of y with respect to x is obtained by differentiating y equals fx n times. We use the notation this one or this one for the nth derivative. Points of inflection. There is a point of inflection at x equals a if second derivative of f of a equal to 0 and the sign of second derivative of fx changes at x equals a. In other words, a point of inflection means two things. First of all, the second derivative equal to 0. Secondly, the sign of the second derivative change at that point. The point of inflection corresponding to a change in curvature. Also, you could say the point of inflection corresponding to a change in concavity. There are two types of inflection point. One called the non-stationary inflection point, which means the first derivative not equal to 0, but the second derivative equal to 0. The other is called the stationary inflection point, which means the first derivative equal to 0 and also the second derivative equal to 0 at this point. Remember, at a point of inflection, the second derivative has a sign diagram like this too, which means the sign is changing for second derivative of fx at a. Let's draw a conclusion. The inflection point at x equals a, first of all, make sure the second derivative equal to 0 and concavity changes. In other words, the second derivative of fx has a sign change at x equals a. We call this point is a stationary inflection point because the first derivative equals 0. This point we call this is a non-stationary inflection point when the first derivative is not equal to 0. Guided practice 2. If the second derivative of f of 0 equals 0, it's 0, 0, the inflection point on this graph. First of all, we check the concavity. You see, for x less than 0, the concavity like this is a concave up. For x greater than 0, it has a concavity down. In other words, at x equal to 0, the concavity changes. Therefore, 0, 0 is the inflection point. For number 2, if the second derivative of f of 0 equals 0, it's 0, 0 the inflection point. Let's check concavity. For x less than 0, the graph is a concave up. For x greater than 0, the graph is a concave up too. Since concavity didn't change at x equal to 0, therefore 0, 0 is not the inflection point. If second derivative of f of 1 equal to 0, it's 1, 0 the inflection point. Same thing, you need to check concavity. When x greater than 1, this is 1. We see this is a concave down. When x less than 1, you could see it's a concave up. Since the graph has a concavity change at x equals 1, therefore 1, 0 is the inflection point. Now let's talk about the sign for second derivative. If second derivative of f of x less than or equal to 0, then the graph on this interval will be concave down like this. When second derivative of f of x greater than or equal to 0, then the graph on interval s will be concave up like this graph. In other words, when you see the graph concave down, means the second derivative less than or equal to 0. When you see the graph is concave up, means the second derivative greater than equal to 0. Find the sign of second derivative for each graph. You have to know how to decide the graph is concave up or concave down. Let's check A. We could see the graph will be like this. It's part of concave up. Therefore, it's a positive. For B, we know the graph like this. So it's a concave down. The sign of a second derivative will be negative. For C, graph will be like this. So it's a concave up, which means it's positive. Don't be affected by the arrow when you decide it's concave up or concave down. Like D, we know it's a concave down, so it's negative. For E, you could see the graph like this, so it's concave down. It's negative. For F, graph will be concave up. Therefore, it's a positive. Guided practice 4. Find the intervals on which second derivative greater than 0, second derivative less than 0, or second derivative equal to 0. Greater than 0, that means concave up. Less than 0 means concave down. Equal to 0 for second derivative means inflection point. Remember, concavity changes. First of all, for second derivative greater than 0, check concavity first for each part of a graph. This is concave down, concave up, concave down, concave up. So for concave up, it will be from negative 0.5 to this 3. Also, it's from 3 to this infinity. Therefore, we can write down negative 0.5 to 3. And also from 3 to infinity. Let's check a concave down. Yeah, this graph. Therefore, for second derivative less than 0, it will be from negative infinity to negative 0.5. For second derivative equal to 0, check inflection point. This is inflection point, and this is the inflection point. Therefore, second derivative of negative 0.5 equal to 0, and also the second derivative of 3 equal to 0. This is a stationary inflection point. This is a non-stationary inflection point, because for x equals negative 0.5, the first derivative is not equal to 0. But for x equals 3, the first derivative equal to 0. Let's draw a conclusion. When first derivative less than 0, that means the graph is decreasing. Like these two graphs. When first derivative greater than 0, which means the graph increasing. Like these two. For second derivative less than 0 means concave down. Like these two. For second derivative greater than 0 means concave up. Like these two. How to remember that? Basically, you can draw a happy face. Draw the people is smiling. Like this. And also draw the eyeball. Like this. And for first derivative less than 0, and then the first derivative greater than 0. This is a second derivative less than 0. This part is a second derivative greater than 0. This is a very important you need to remember. When f is concave up, the second derivative is positive, and the first derivative increasing. Because when we do the derivative of a first derivative, you will get the second derivative. Therefore, the slope of a tangent line of the first derivative means second derivative. That's the reason when second derivative is positive, the first derivative increasing. When f is concave down, means the second derivative is negative, the first derivative increasing. For this chart, we can add the first derivative equal to 0. When first derivative equal to 0, this x could be maximum or minimum point, or it could be stationary inflection point. When second derivative equal to 0, and also concavity changes. There are two types of inflection point. Could be non-stationary inflection point when the first derivative not equal to 0. Or it could be stationary inflection when the first derivative equal to 0. Let's go to guided practice 5. In the diagram shown, B and D are stationary point. C is a point of inflection. Complete the table by indicating whether each value is 0, positive or negative. Let's talk about the sign for f of x, or the first derivative of x, or the second derivative of f of x. For f of x, positive means above x-axis. Negative means below x-axis. For first derivative, positive means increasing. Negative means decreasing. Second derivative of f of x, positive means concave up. Negative means concave down. Let's talk about when f of x equal to 0. That means x-intercept. When first derivative of fx equal to 0, it could be maximum, minimum, or stationary inflection point. When second derivative of fx equal to 0 means inflection point when concavity changes. Therefore, let's figure the table out. For f of x, above x-axis means positive, so A is positive. B is a negative because below the x-axis. C, D, that's a positive. E is on the x-axis, that's x-intercept will be 0. Check the first derivative of fx. Positive means increasing. Therefore, we could say C is a positive. Decreasing, that will be E. And A is a negative 2 because it's a decreasing. The maximum and the minimum value for first derivative will be 0. Therefore, B is 0 and D is 0. For second derivative of fx, just check if it's concave up means positive. Therefore, you have A is positive, B is positive, C is a inflection point given from the information here. C is a point of inflection, therefore it's 0. Look at the D and E, it's a concave down, so both negative. For B, describe the turning points of y equals f of x. That means B and D. Describe the inflection point of y equals f of x. That's C.